In this video, we're going to learn about some of the properties of logarithms. These properties will allow you to either simplify expressions you have or solve equations. They're also useful in problems in future semesters, letting you solve other problems easier by rewriting how your expression looks. But for right now, there's really going to be two main problems that we'll get covered into here. Before we get this, go over the properties. The first property is one of the ones you're going to use the most often, is that when you have two logarithms that have specifically the same base and you are adding them, then you can combine them into a single logarithm by multiplying the insides. And the reason why this works is that if you think about it, if you have, say x cubed times x to the fifth, what do you do with the exponents? You add them, you get x to the eighth. So this is just saying is that multiplying the inside is the same as adding the exponents, because remember what logs are the exponents. Similarly, when you are subtracting here, that corresponds with dividing on the inside. And the last of the three main rules is that having a coefficient or a number in front of the log is the same as having a power on the log. And this goes along with if you have x squared parentheses cubed, you're supposed to multiply the exponents. So you see how you had to take 3 and multiply it times the current exponent. Now the next formula here is called the change of base formula. This allows you to convert one log in any base into logs of other bases. The usual ones we would use is natural log or the log base 10 here. And this used to be a much more important formula because calculators that you would buy and have on hand would only have, like, say, just the log base 10 button on them or just the ln button on them. And this will let you do, for example, you wanted to find out what log base 3 of 5 is. Back in the day, you could not put that in your calculator directly, but you could put ln 5 in your calculator. You could put ln 3 and you could divide them. Nowadays, a lot of calculators are starting to add in buttons where it looks something like log and then gives you two blank boxes here. And then now you can put whatever base logarithm you have on there. So as a result, this formula isn't as necessary as it once was, although there are still times where you're going to want to use it. These last properties here, these don't get used nearly as often as the other ones in this section, but they do get used in future sections to simplify things. First off, log base any base b of 1 always gives you 0. That's because anything to the 0 power gives you 1. Log base b, whatever b is, of the same number always gives you 1, because again, b to the first power gives you b. Rules 3 and 4 here are just dealing with the idea that exponentials and logs are inverses. So if you do both a log and an exponential, in some sense they cancel each other out, leaving you with just the x there. And the last property was talking about how you can take any base exponential and you can convert it into an e exponential, which right now doesn't seem all that important, but it's going to be very useful in a calculus class, so we at least mention it right now. With all that said, let's get down to the two main types of problems. The first type of problem is we're going to give you a bunch of terms with different logs involved, and then your job is to combine them together using these properties into a single logarithm. You could think of it as like simplifying the expression. So what I would recommend doing on these problems, first things first, is any coefficients you have, go ahead and put those onto the exponents. So I would have log base 3x plus log base 3 y to the fifth minus log base 3 z squared. And then I would say, okay, well, I'm adding these logs so I can multiply them, and then I'm subtracting log of the same base. It's going to divide it, so I can combine this into log base 3 x times y to the fifth over z squared. And this would be the most simplified expression we can have here, we've combined it down to a single logarithm. Similarly, on the second one, we look for any coefficients to become exponents, and that's about it there. This then becomes ln x plus 1 squared plus ln x minus 1 minus ln x squared minus 1. And then we have our pluses and our minuses by combining logs to being multiplying and dividing. So I'm going to have an x plus 1 squared times an x minus 1 over x squared minus 1. The difference here, though, is that you can actually factor this. So x squared minus 1 is x plus 1, x minus 1. I can then do some cancellations here. And the final simplified answer would just be ln x plus 1. Okay, so that first type of problem, again, is just taking logs that are a bunch of separate logs and combining them together into a single one here. You could think of that like simplifying algebraic expressions. The next type of problem is basically the exact opposite, where we have a single logarithm and we want to break it up into different pieces. Now you might think, why would we do this? Why are we, reversing simplifying? It's because there are going to be some problems in the future where they will become much easier to solve if you can handle the little individual pieces separately rather than handling this one big monster all at once. So what you can do is you can say, okay, I have two things divided, so I go log of the top minus log of the bottom. And then I'm going to go ahead and do another step here where I have two things multiplied inside here on the bottom, so I will break that up by a plus sign. But I do need to be careful here is that I'm subtracting this entire logarithm. So when I break it up into two, I need to have this with parentheses so I can distribute the negative in. Next thing I'm going to do is I'm going to write out with exponents here, x squared plus 1 to the 1/2 power. And then the last step will be putting exponents in front of the logs. And there we go. So that gives us our expression here. And I kind of want to point out that hopefully after 3 examples, related to these, you can kind of see comparing like the final simplified answer versus the unsimplified answer. And you can essentially do a shortcut here. Anything that's in the numerator is going to be a plus, anything in the denominator is going to be a minus, and all those exponents go to coefficients. So if you want to do this really quickly, you could say it's going to be 2 log 2x plus log 2y minus 3 log 2z minus 5 log 2w, and then you get the answer right away. So again, for this section, you should understand the properties and how to use them with really only just 2 main types of problems here.